It is always an honor to be here, and I do also want to thank you. What is your name? Hey, sir, what is your name? One more time, I'm sorry. Jitain, thank you. Remind me, how is it? So I apologize for that mild panic here for a moment. In my haste this morning, between the keynote and now, somehow I managed to make my adapter disappear. And I am going to move this thing right here. It's making me awfully nervous. All right, let me just make sure I've got everything sort of wired up and where it ought to be. Wonderful. You know what? I'm really excited to talk about this technology. I haven't gotten this excited about some back-end technology in a very, very long time. And the more I learn about this, the more excited I get, more impressed I get. Now, I want to ask before we begin, how many people have actually heard about Micronaut, heard of it, use it, anything like that? Okay, so about 5 or 10% of the room. So what I'm going to do then is I'm going to take just a moment in the course of the talk here and give you a little bit of the background about what it is and a few of the reasons why I'm so excited about it. So just to kind of dive through the agenda, everything I'm going to try to cover in the next 60 minutes, and we'll see, because you know how I like to talk. I'm going to try to write some code in the process as well. But basically, for the majority of the room, the people who didn't raise their hand, I'm going to answer this question right away. What is Micronaut? And then from there, we're going to talk about why there's another framework. I think that's always an important question to answer anytime you're talking about any kind of new framework. Because I feel like the why question is not something that we ask enough as software engineers. Whether it's something we're adopting or something we're building, being able to answer and articulate that why is a really valuable thing to do. So I'm going to try to answer that very quickly, talk about the challenges of microservices, and then we're going to get into the meat. We're going to build a couple of things. And this is all really exciting stuff. And then we'll go into the installation, build a kind of quick hello world service to kind of give you an idea of the core of Micronaut. And then we're going to solve a big problem that we deal with anytime we're building microservice applications. That no matter how hard we try, no matter how well we designed these microservices, no matter how well we are, what a good job we do defining these bounded contexts, there are inevitably cases where we have to communicate between one service and another. And often it's not even as simple as that. It's one to another, to another, to another. And the problem is you lose that resiliency. You lose that resiliency when one of those fails. Because the whole idea of isolating everything up is that if one fails, everything else keeps running. But when everything is reliant on everything else, as soon as one fails, everything falls apart like a house of cards. And the solution to that is decoupling these things. When you're creating these inter-service calls, too many of them, the solution is to decouple those so everything is running independent of everything else. So we're going to talk about building that. We're going to put together an example application that does exactly that. Starts calling, dropping messages into a queue. Now we're going to use RabbitMQ, but that's just a great example that we can dive into easily for the purposes of a demo. You could easily be using Kafka, and one of the great things about this framework, Micronaut, is that they're evolving it and adding capabilities every single day. So in the beginning, when I first started playing with it about a year or so ago, all that was available was Kafka. Now they've added RabbitMQ. And we're going to talk about serverless stuff as well. In the beginning, it was just Amazon AWS Lambdas, and now it's GCP. Now you can deploy your Docker functions and OpenFast. And so there's a lot of really, really cool stuff in this. So I want to try to get through all of this, go work through an example. But let's answer that question, that first question right away. What is Micronaut? And to quote the folks who are behind Micronaut, if you've used Grails, if you've used any of those kind of technologies in the past, it's the same team that created Grails, created Micronaut. And in short, it's a modern JVM-based full-stack framework for building modular, easily testable microservice applications. It's very fast. It's got a low memory footprint. And it's got very easy configuration, if there's any configuration at all. It's got a nice set of bundled dependencies. It's got a great programming model that if you've used Spring, if you've used Grails, and you love that, you get all of those benefits. But, and this is a weird thing for me to say, without any of the magic. Like, yes. Well, is it without any of the magic? This is one of the biggest complaints I've heard from developers in the past when we talk about things like Spring. I've heard so many developers say, I don't like using Spring because there's too much magic. Now I love the magic. Bring on the magic. But I understand their concern because magic is great when it works, but not when it doesn't. Not when somehow one line doesn't add up to 176. All of a sudden, it's like, I don't know what I'm doing. But with Micronaut, the way it works, the core architecture of the framework is there is no more magic anymore. Or there is, but at the same time, at any point you can go and pull the curtain back and see everything that's going on under the hood. And we'll talk about how this is accomplished. So the reason we have another framework, to answer this question before we dive into anything, the reason we're diving into a brand new framework, rolling out yet another framework, is very simple. That the frameworks that we're using today have been around for a very, very long time. Now, I'm going to compare Micronaut to Grails. You could make the same comparison comparing Micronaut to Spring. But to look at that, we have to go all the way back either to the early days of the Spring or early days of Grails. We go back all the way back to Grails 1 or even Grails pre-1.0. In those days, if you were building applications in web applications at all, or really any kind of application, the state of the art was probably Struts 1 back in 06. So Grails came back out in 2006. And so the state of the art at that point was probably Struts 1. And Struts was a big improvement over what you had to do before that. If you're using Java to build web applications, you were probably writing your own servlet class with do puts and do gets. And I'm looking at Scott. He's smiling. He remembers doing this. I guess what I'm trying to say is Scott is old. It's a little bit of gray there. We might be some of the oldest people in this room. I don't know. There's a lot of young faces here. But the thing is, in those days, when we were doing exactly that, writing our own do put, do get, servlet classes and things like that, we looked at this and we said, okay, there has to be a better way. Because there was lots of boilerplate, lots of configuration, and thus some of these newer frameworks were born. And it just came from that observation. There has to be a better way. There has to be a better way. And Grails was a better way than Struts. And the framework has evolved. As the demands have changed, as the way we've built applications changed, the framework's evolved. If you look at Grails today, and Grails 4.0 is in milestone phase right now. They're about to release a new version of Grails. And again, you can make the same comparison with Spring. It is very, very different. And but what's worth noting is both of those frameworks at that time, they were designed from the ground up to facilitate the development and deployment of monolithic applications. And if we look back 10 years ago, to give you an example of this contrast, we weren't building web applications the way we are today. And so RESTful services were a thing, but they weren't a very popular thing. It just wasn't anything we were doing much with in 2006. And then as the way we built software changes, the frameworks evolved. And you can compare these back and forth again and again and again. If you want to do REST, back in those days, if you wanted to do REST, and people did occasionally do this, you'd have to write your own marshallers. You'd have to write your own data binders. And as REST became more relevant, became more mainstream, all these capabilities got added to the framework. And they added and added and added and added to the framework. Done the same thing with Spring, added and added and added to the framework. But the core, the foundation is still the same. So we're adapting, and this is why these frameworks remain relevant, is they keep adapting. 12 years ago, when Grails came out, the way you deployed an application is you put everything into a giant WAR file, and you would deploy that. And that is not what we're doing today. And the key thing is, though, those frameworks were originally designed to facilitate the building and deploying of monoliths. And so the folks behind Grails, and Grails, as you know, is built on top of Spring. Grails 2 is built on top of Spring MVC. Grails 3 and 4 built on top of Spring Boot. It always has been, and the thing is, the people behind that, they had some decisions to make. They realized that this microservice thing is not going away. that this is becoming the dominant architecture for modern distributed application, for modern applications that run at scale. And so the question was, do we shoehorn more capabilities into the frameworks, or do we build something from the ground up that takes everything we've learned from these frameworks, everything we love about these frameworks, but built and designed to build microservice applications instead of monolithic applications? And I should pause, by the way, and I want to say two things. First of all, monolith is not a pejorative. In other words, one of the biggest things that sort of grinds my gears, one of the biggest things that troubles me as a speaker, as an engineer, as just somebody in this field, is that there's this idea, this notion, that monoliths are how we used to build applications, and microservices is how we build applications. And the reality is, they are two perfectly legitimate architecture patterns. And they solve different problems, and they each come with their own benefits and their own trade-offs. And you use the right tool for the job. And I've seen too many people kind of run down this pathway of building everything in the microservices when it was the absolute wrong decision to make, and then learning from that mistake and putting all of their microservices back into a monolith. In other words, people have looked at their current situation and they say, oh, we've got this giant monolithic ball of mud. We need to refactor it. And instead of actually making it less of a ball of mud, they just break it up, and now they have 2,000 balls of mud instead of just one. And it turns out it's infinitely more difficult to keep track of that. So the first thing I want to say is this: I'm not coming at this from the perspective that this is the only way to build applications. It's just one way to build applications. And if I can do nothing else but kind of put the brakes on this notion that one is good and one is bad, then I'll feel like I've done something useful. And the second thing is that I'm not saying you can't use Grails or Spring or whatever to build microservice applications. You can. People do all the time. In fact, if you're building microservices right now, you're probably most likely using one of those frameworks. And if we're realistic, it's probably Spring. You can do this. But what I am saying is that those frameworks weren't designed from the ground up to build microservice applications. And even today, even in 2019, you find this manifest itself in various ways where you just start to feel some of the friction trying to do that. So the idea is they had this decision to make. Do we continue to shoehorn these capabilities into the framework, or do we build something new from the ground up, designed to be better? It's exactly where we were 12 years ago, 13 years ago. There has to be a better way. And the more I learn about Micronaut, the more excited I get and more impressed I get. And the idea is to take everything we love about these frameworks and none of the things that we don't do. In other words, everything is sort of bundled together. The startup time is extremely fast. The memory footprint is extremely small. The jar sizes are very, very, very small. And you get that same productive programming model without all of these downsides. And the way they do this is they do everything, or as much as possible at least, at compile time instead of runtime. Instead of doing runtime reflection to discover all of these annotations and scan your class path and read your beans, doing all of this stuff at compile time. And the results, and these are OCI's numbers, and I want to point this out. I copied this from OCI's website. And my own personal benchmarks weren't quite this shocking and quite this contrasting, but I think any vendor that's kind of promoting their own new technology, they've always got their thumb on the scale just a little bit. They're trying to paint the rosiest possible picture. But the results are there, and the results are good. The startup time has been very impressive. The bundled dependencies have been very impressive. And the way they do this is all the DI, all the dependency injection, aspect-oriented programming machinery, all of this stuff happens at compile time. It resolves all of this stuff at compile time. And as a result, you don't get the overhead of reflection at runtime. Because a lot of the syntactic sugar that we all love in Spring relies on reflection. You build a class, you annotate the methods, and at startup time, Spring has to discover those annotations of those attribute values And separate from the reflection, Spring has to read the bytecode for all of the beans in your application context. And this isn't just reflection, this is literally reading the .class files, because Spring has to know what's there before loading or what to load and what not to load. So the challenge, like I said, this, the I/O gets expensive. As your lines of code increase, so does the cost. So the challenge is getting into this better way. And this is where we end up with Micronaut that has a lot of really, really cool stuff in there. One of my favorite thing is it is natively cloud native. If you're trying to pursue the ideal of a 12-factor application, so much of this is incredibly easy, incredibly trivial in a lot of cases. And I wish I had an entire day to talk about some of these things. Service discovery is literally, it's not even annotation, it's a configuration. You turn that on and it knows to use, whether you're using Eureka or Console. Configuration is easy, it integrates with whatever cloud in a configuration platform you want to use, or a lot of these other ones as well. It's got efficient service integration. All of this is literally just annotations. Tracing, if you want to use something like Zipkin, or I'm drawing a blank on the other one, the other kind of popular tracing. Oh, so is Scott. Security is built in. The resilience, it's literally just annotations. If you want to implement failover or fallback or circuit breaker patterns, it's literally just an annotation on the interface you're defining for your client. There's so much cool stuff in there. And so this is literally just, it's when you start playing with it, you'll start to feel as excited as I get. If you want to install it, it's pretty straightforward. I'm running on a Windows machine, so it's literally just a case of downloading the binaries. If you're on a Linux-based machine or Mac OS, it's just a case. I use SDKman to install this, and you can check this out in the examples here, but for now, let's actually just dive in. Let's create a little simple Hello World app. And I'm going to try to jump into here and bring up a going to try to bring up my IDE or something. And what I want to do here is just build a couple little simple things, and then get, and then dive in just a little bit deeper. Any questions so far, by the way, while I'm... Any questions so far?
How does it compare with Spring Boot?
So the biggest difference, and if you look at their benchmarks that they have, startup times are dramatically smaller, the jar sizes are smaller, the memory footprint goes down quite a bit, but you have the same kind of capabilities and the same kind of model. One of the mistakes I've seen people make when migrating, or not migrating, because it doesn't make any sense to migrate from Spring Boot to Micronaut, but if you're building something new, that makes sense to say, okay, I'm going to build something new, so I'm going to use this particular technology to try this out. Because that's one of the beautiful things about microservices, it's that they're all their own little thing. So the only thing that I've seen people do that's a mistake is they start working with Micronaut, they say, wow, this is really fast, this is really lightweight, and then they'll bring in something like Spring Security. And the thing is, Spring Security still relies on runtime reflection, because it's got to scan all of those annotations again. So what the Micronaut team has done is they've built in their own security platform or security dependency that's already integrated, that again does everything at compile time rather than runtime. So let's see if we can do this. And I'm just going to create a really simple example here. And let's see, jump over here. I'm going to create, well, let's do this. So I'm going to cd the projects. I'm going to, okay. And I'm just going to use the Micronaut CLI, which is the standard tooling for a lot of these things. either scaffolding new projects, adding capabilities. There's a lot to talk about just in there, but I'm just going to say mn create app, and I'm going to call it GIDS service. I'll just call it the GIDS service or something like that. And this might work, it might not. I'm not sure what my wireless situation is going to be. And if not, I have one that I made earlier. But it's a really simple process, and I'll show you, I want to show you just kind of what this looks like, and also the integrated HTTP client as well. Okay, it looks like that did something. So let's go in here, we're going to open that up, go into projects, go into GIDS. And I have my GIDS service. So I'm gonna open that folder, and when my text editor wakes up. By the way, I just want to make sure this is pretty legible for all the folks here. Maybe not this on the side, but is that good size, readable, a little bigger. Why you no Zoom? How's that? Yeah? I'm not sure if we can we do that? I wonder if I can switch to a light theme. I'm not even sure about that. Well, let's do this, just to kind of do this quite quickly. I've got this service in here, and if I just go in here and I jump into GIDS service, and I just great old W run, I can kick this off. It's going to compile, it's going to build. Not much is going to happen because I haven't really defined any behavior at all in here. And so I want to do that. I want to go and create a controller, create a real simple service. So that's going to start the daemon there. So in my GIDS service, what I'm going to call this is just going to create a microservice controller that's going to take some kind of string and do something. We'll just make this a real simple kind of hello world. So I'll call this hello controller.java. And in here, very simply, we'll create an endpoint here. So I'll create a package, call it Nova. Import io.micronaut.http.annotations, and I'm going to annotate this class as a controller, and I'm going to specify this path here, and so it knows that all of the root paths are mapped to this particular controller, and I'm going to say public class hello controller. And in here, I'm going to create a method that I'm, again, going to annotate this with the get annotation. And you'll notice right here what we're doing is you'll recognize this as string interpolation. And so this is the path we're defining for this particular controller method. So if I just jump in here now, I can go in and say public string index string name, take name as a parameter. It knows to map that automatically. And in here, I can just return hello and name. And so this is a pretty simple hello world type service. So if I jump back over here and I terminate that and I just run this again in Gradle, then it's going to kick off a build, it's going to fire that up, and it's going to run on port 8080. So I can go over here and let that do its thing. So I can just say curl HTTP localhost and 8080. And hello, and Scott, since you're right there and I know how to spell your name. And obviously it comes back, hello Scott, and we've got our microservice. And there's not a whole lot that goes into it. There's really just some annotation. And so one of the things, if you are doing any kind of inter-service communication, by the way, how are we for time? We're halfway through. I might move a little quicker. You know, if we are doing any kind of inter-service communication, there's some really cool tricks to do this. So I'm going to create a little test in here, and well, maybe not because I did. Well, yeah. There's a couple different ways that you can interact, and one of my favorite little features is when you create an HTTP client. There's a couple different ways to do this, but at its core, you really just define an interface. And I'll kind of show you what this looks like, and then I'm going to keep moving. So I'm going to create, if I was to create a test in here, we could create like a Spock spec. So mn hello controller spec dot groovy, and the same kind of thing in here. I'm going to close that drawer. I'm not even sure what that is. And I'll show you what this looks like, because you're going to see this pattern repeated over and over and over again. So in here, I'm going to create my package, and I'm going to define a client, and I'm just really going to define an interface. That's all I'm going to do. So I'm going to say get hello name with that annotation, and I'm just defining the contract for this particular interface. That's kind of the key thing. So here, I just define the client, and I annotate it as client, and I map it to that path as well. But if I'm using service discovery, all I do is change that annotation to being a literal path, to being an ID that gets looked up in some kind of service discovery tool. I tend to use console for these things. And now I can create my class, my hello controller spec, which is a Spock specification. It's going to extend specification. But really, I create a shared auto cleanup resource, which is going to be my embedded server. Embedded server equals application context dot run embedded server. And I'm going to create one more resource of type greeting client. I'm going to call it client equals embedded server application context dot get bean greeting client. Now, where's that coming from? Where am I getting this bean, this greeting client bean? I've only defined an interface. I haven't defined a concrete anywhere. And that's one of the things that happens is that when you build an application, Micronaut scans at compile time for any of these annotations that mean something. And in this particular case, it creates a concrete instance of this client that handles everything that we possibly need. So once I have this client in here, I can define a test method so I can test my message. And basically, I'm just going to expect, and I'll just make a call to my client that I've defined, client.helloMichael equals hello Michael. And in theory, this test should pass. So you're going to see this pattern over and over and over again, because what we're going to do here in a moment is we're going to build an application that is now decoupling this inter-service communication. So instead of just creating a client and making these cross-service calls, we can drop a message in a queue and just be happy that that's handled. And then the subscriber, we publish that, and the subscriber is actually going to take that message and process it in his own time in parallel with its own independent scalability and none of the downsides. So let me jump back into here, because I want to keep going. And how are we for time? So we've got here, so we'll talk a little bit about these event-driven microservices. So one of the nice things with the example that I created a few moments ago, I just used the CLI to scaffold a new microservice application. And this was going and using just kind of a standard RESTful microservice. But we can take this a lot farther, because the CLI also has a bunch of profiles built into the CLI for Kafka-based or RabbitMQ-based message applications. So the profile that we can use there will basically create a Kafka app with Micronaut support and without the HTTP server. Although you can add one if you want to. The profile also gives you a couple commands for generating Kafka RabbitMQ listeners or producers. And I'm sure everybody in the room here is familiar with RabbitMQ. If not, that's basically what it is. It's just a messaging. It's just a message queue. It's very fast. It's robust. It's been around for quite a while. So let's actually build this. So I'm following one of the examples that is in the Micronaut guides, which were available online. And this is one of the things I would highly recommend that you check out. One of the things that gives me a lot of hope about any new technology is the community behind it. And seeing what the community is producing around these guides and tutorials and the documentation, it makes me feel pretty good about this. But this particular example, we're extending an existing microservice application that is some kind of book service where you can look up and get data about particular books. what we want to do is we want to add analytics to this so we can get data on how frequently books are accessed. Now, normally that analytics would be outside of the bounded context of the application, so that's going to go into something else. But we don't want to create that tightly coupled dependency. We want to keep those two microservices decoupled. So we have two services. We have the book service that will return a list of books, and so the bounded context of that, the domain of this is literally just the books and the ISBN numbers, but it's also going to publish a message into the RabbitMQ queue every time a book gets accessed. And now we have the analytics, which is going to connect to RabbitMQ, and it's going to update these analytics every time somebody looks at a book. And so it's basically a very simple counter, and it's going to expose that as an endpoint to get the analytics. So I've already pulled down the example here, and if you look at the slide, you'll see right here, I've got a list on the slides. You can actually download the completed tutorial if you want to walk through that. But we'll jump back over to our trusty text editor. And let's really just kind of start putting this together. So to give this to you right now, under the book service, we already have a couple basic things. I can run this book service right now, and I can get books by ISBN, I can get some data, and I've added a couple of dependencies in there. So one of the first things that we're going to have to do this is to go in and run my Docker container. So I've got a Docker container that's going to basically spin up a Docker instance that has RabbitMQ running in it. So once that fires up and does its thing, it's going to sit and run. And hopefully, in theory, we can kick off we can see that this is up and running. So if I go to localhost, yes, I'm using Bing. Don't judge me too harshly. I'm angry at Google, and this is kind of, I don't know if they have this idiom here, to cut off your nose to spite your face, but I think this is kind of exactly what it is. Localhost 5672. I think that's running. I think I mapped that right. Anyway. So this is off running and doing its thing. Oh yeah, I've hit the wrong port. But we've got this service right now. We've got RabbitMQ running. So in theory, if I did go into my projects folder, I'm still getting used to using Windows. GIDS reactive, right? No, it's not there. So if I go into here, into my Micronaut, RabbitMQ, into my book service, I could run this with Gradle, and I could start making some requests out to this. So there's a couple different endpoints in there. If I just show you the book service here, in my book controller, I've defined a few services here. A get will get a list, or I can get with an ISBN, and it'll find the book. So we've got a couple of endpoints. But what we want to do is add in this this analytics microservice. So one of the first things we're going to have to do is create this analytics microservice. And so in our analytics, one of the first things we'll have to create is this analytics service. And there's not a whole lot that's going to be in here. So this is going to be a package, example.micronaut.analytics. And in here, we're just going to import a couple things. So we're going to create a bean here that this is really going to be our endpoint. And we're going to grab a couple other things, java.util concurrent. So I'm going to use a concurrent hash map. Basically, for the purpose of simplicity, we're not going to create any sort of persistence layer. We're really just literally going to keep this in memory inside of a singleton. And I'm also going to use the Java stream collection. So I'm going to annotate this as a singleton. And by the way, I do want to point out that this annotation, the singleton annotation, this one isn't a Micronaut annotation. This is an actual JSR 330 annotation. It's got its own DI framework kind of built into it as well. But I'm going to say create an analytics service class, analytics service, and in here I'm just going to say private final map. And this is where we're going to store these in memory, and then I'm going to create a method. This is actually going to do the work here. We're going to initialize and update the analytics for the books that get passed into here. And just some pretty simple, nothing really particularly fancy in here. By the way, this is also just one of my little tests just to kind of see. Trying to get a feel for the room, and I don't know if you notice as I'm going through here, is using spaces for indenting. If I see anybody leaving, I'll understand why. Return, our analytics, our entry set. So just a couple things are going to go in here. And the other thing I want to do is have a method here that's going to return all of the analytics. So nothing particularly fancy in here. Collect to list, and that's pretty much it. So one of the next things we're going to have to do is create a POJO to store some of these analytics, these book analytics.java, and I believe watching me create a POJO would be one of the most tedious things that you could possibly do. So I'm going to cheat, and I'm going to copy and paste on that one. And so now that I've got these two pieces in here, we can actually test what we've done so far. And in here, I've already got a test. I didn't want to sit and write a test live. I don't think that would add a lot of value. But really in here, we're just defining a test, and this is using JUnit. So the other test that I wrote was a Spock test. But by default, and you can specify Spock as a desired feature when you're when you're scaffolding any kind of new project. But by default, it is JUnit. And so what this test will do is it will just go and it will make a few methods, make a few calls out to the update book analytics method, and it's just going to assert that the values are what we really expect them to be. So if I come out of here and I go over to my analytics service, I can Gradle W test, and this should go, now that all this is in place, assuming that I saved my work, I can go and run my test. And in this case, my test should pass. They don't, and that's always just how live coding goes. Haha, so we'll just keep going. So we got a test in theory that our test will pass. So we're going to have to do a couple of things here. One is we're going to create a controller to expose all of the analytics. And by now you know that this is a pretty straightforward process. So I got my package, which is example.micronaut.analytics, and I'm going to import a couple things, just a few simple annotations. So the HTTP annotations for a controller, because this is a service endpoint where we can actually call and expose this. I've got the HTTP and the get annotation, and I'm also going to get the Java utils. So again, just like my example that I did earlier, I'm annotating this as a controller, and I'm creating an analytics controller class, and I'm creating a private final analytics service, and controller, and we're going to inject this in. And we didn't talk really much about dependency injection, but I think we're all pretty familiar with this at this point. The DI framework inside of Micronaut is very robust. It's full JSR 330 compliant DI machinery. So we can get a list here, return analytics service.list analytics. And we're going to have to create well, we've got that service there. So I can save that, and then I can, and now probably our test might pass. But we want to do a few other things. Now, we want to set up the InterService Communication with RabbitMQ. So there's a couple things that we have to do. One of the first things that we have to do is actually start RabbitMQ. And we've done that. I use Docker usually for any of these sort of examples. And then in our books service here, the books microservice that we created earlier, there's some configurations in the build.gradle where you want to make sure that you've got the compile time dependency of RabbitMQ in the book microservice. And we want to make sure that RabbitMQ is configured. And all of this has already been kind of created. So in the books, we have to do a couple of things. In the book microservice, one of the things that we want to do is create, and this is the wrong place, in our books, we want a channel pool listener. And basically, there's two different ways that you can set up RabbitMQ to receive messages. You've got to define the exchange, you've got to define the queue, define the binding. So you can go and manually do that inside of, you can manually define this inside of RabbitMQ by going to, by actually loading up the UI, or you can define this as, is basically create them programmatically. So we're going to import a couple basic things, the client channel and the Micronaut channel initializer, RabbitMQ connect channel initializer. And then we're also going to get our Java singletons and the IO exception. So again, I'm going to define this as a singleton. And this is my channel pool listener. This is going to extend the Micronaut channel initializer. And I'm just going to override the default method here, the initializer method. Channel throws exception, channel, exchange declare. And I'm just going to call this Micronaut built-in exchange type direct. And I'm going to define my queue, call it analytics. And finally, I'm going to create my queue bindings. And that's pretty much all that we need in here. So one of the next things we have to do is to create the client. This is going to be the producer. And you remember how we created the HTTP client. We literally just defined an interface, annotated it as a client, and Micronaut took care of building the concrete. So we're going to do the exact same thing here on the analytics client. And so literally, it's just this interface. And I've got this Rabbit client interface. And because I've set everything up, I've set the exchange up, and it knows that it's using the Micronaut exchange and it's binding to the analytics queue, that everything is basically all set up. So now the last thing that we want to do is we've got this existing microservice, but we want to add this analytic capabilities. So we're going to create an analytics filter in here. And what this is going to do is it's going to send the analytics information programmatically. So I'm going to create another packet, create this package, import just a couple of things. So the HTTP request, because what I want to do is be able to intercept the HTTP requests. I'm going to import the response, annotation, filter, the server filter. And the idea here is I can essentially just every time a book gets returned, do this automatically, have a message get dropped into the queue. So we've got the reactive strings, the publisher, and finally we're going to get the Java optional. So here is the path that we're creating a filter on. So it's our analytics filter, and this is going to implement an HTTP server filter. And in here, we've got an analytic client that, again, which we've never created the concrete of this. This is automatically getting generated for us. And we've got the analytics filter here, which is going to inject the analytics, this is our constructor rather, which is going to inject this analytics, and we're going to store this in that private final variable. And then in here, we're going to override annotation public, publisher, and we'll do filter, and it's going to take the HTTP request, the server filter chain, and we're going to return flowable from publisher. And so essentially, ultimately, we're going to drop this message into a queue, which is going to, in our analytics client, it's going to update the analytics, and then we're going to return our response. And that is pretty much it in here. And this is really pretty much everything we need on the client. So now we've added an HTTP filter that is going to push this out every time somebody makes a request to that service. It's going to drop a message into the queue that's going to get picked up by the microservices. So now we have to create the consumer. And so we need over here our analytics listener. And so what this is going to look like essentially is it's going to be pretty straightforward. We only need a couple things. So we need to import the Micronaut and the queue annotation, so it knows, so we can annotate which queue that we want to pull something out of. We're going to import the RabbitListener annotation, the RabbitListener, and these annotations, what they basically allow you to do is to annotate a method as a listener, and you can annotate the class rather as a listener, and you can annotate the method to listen to a specific queue, and that is going to pretty much wire everything else up for you. So we've got the require, and we've got our environment as well, and this is a useful thing because we don't want to load the bean in a test environment. So I can define this behavior in here, but then I'm annotating the class as a Rabbit listener, and so we got our analytics listener in here, and we're going to inject this. So we're going to need to store this in there. Analytics service, and we're just going to inject this in the controller here, the analytics service. And then the key piece, though, is right here. So it's this class. We're going to annotate this with @queue, and it's our analytics queue that we've created, that we've programmatically created in RabbitMQ. And here it's going to actually do the work to update the analytics. In this case, it's going to do so through the analytics server that gets injected in the constructor, and it's just going to update that for the specific book. So we've got this piece in here, and this is really just about it. So this is all the moving parts to set this up, but really the key pieces are here. In your client, defining that interface and annotating that, and in the service on the other endpoint, defining your class as a Rabbit listener and annotating the specific message to bind it to a particular queue, and from there, pretty much everything just works. So we got RabbitMQ running. We've got let's see. We are in the analytics service, so I can in the analytics service I could go in here and run this. And then we'll actually see all of these pieces work. So that's going to kick off our analytics service. Of course, it's not. And if that's not going to work, then probably the other stuff isn't going to work. And we don't have enough time to sit and debug exactly what typo I made in the process of doing all this. I would say that it works on my machine, except I'm on my machine. So that's all I've got for you. Yeah, I'm not going to dig too deep into that because we've got, how much time do we have left? 10 minutes, okay. Well, any questions so far? Okay? I've either been really clear or I've put everybody to sleep. Maybe a little bit of column A, column B. So, we've kind of covered that, setting that up, and I'm not sure what I did wrong. I actually ran through all of the demos right before I came here, and I'm like, all of this stuff works, great, let's go. And then I don't know, it's something about standing here with a computer that fundamentally changes how things work. That's been my experience, and I don't know if it's just me or if you've ever experienced this, but the other thing that I want to talk about that's really is basically creating functions. Now, whether these are AWS lambdas, whether these are open fast functions, there's not a whole lot that you have to do. Really, at its core, you can use the CLI and scaffold. You can mn create function, and it will set all of that up. But even if you're just scaffolding a brand new Micronaut app, it's just a case of adding the Micronaut function dependency to your class path. And if you're using AWS, there's a function AWS, or if you're using GCP, or if you're using, I know there's a couple different platforms that they use. So right now, when you're defining functions, there are a few supported interfaces. You can use the supplier interface, which has no argument. It just has a single result. You can have a consumer, which takes a single argument but has no result. You can have a by consumer, which will take two arguments and no result. You can create a function which has a single argument and a single result. You can have a by function which has two arguments and a single result. And the input and output of these of the functions, they should always be either a Java primitive or a simple type like a string or a POJO. So if you're creating a function, the simplest way to do this is to use a CLI, the literal mn create function. So Micronaut has a function scaffold there. It has a function-AWS profile. It's got a number of different profiles you can use depending on where you're deploying this to. And so when you do this, it'll create an application. It'll create a function rather than an application with services. And defining the function body, all you're really doing in here, like creating services, functions register. Functions are a simple annotation on the class, and they will register with whatever discovery service you're using. So you'll notice when we created the service, everything that I had in this annotation was kind of a relative path. If I put an ID in there, in this particular case, it would look up that particular ID in whatever service discovery tool you're using, like Eureka or Console. And when you're creating a client, there's a couple different ways to do this, but again, just like we did with the HTTP client, just like we did with the RabbitMQ client, you simply define the interface, and you add the relevant annotation, and it knows to look up that function in the service discovery tool that you're using, whatever it is you're using, and Micronaut itself at compile time will generate that concrete. And if you want to test the functions, there's a couple different ways you can do. You can call them directly in a test. You can run them locally, and you can also spin up the entire instance. Because Micronaut has that very fast startup time, it makes it entirely reasonable to spin everything up even in a unit test concept. Now, you could argue whether or not it makes sense to do this as part of a unit test, but you've got that particular piece. You can also run your functions in CLI applications, which is an approach you'll probably see often with some of these function as a service projects. But you can execute jar files. If you've got AWS Lambda functions, you can deploy them directly to AWS. If you've got, you can call them from Gradle. You can run them directly in IntelliJ. And the only thing I would add, by the way, if you're using this with IntelliJ, there's one single configuration option you have to set in your settings in the build execution, and you basically have to go into the settings and check the enable annotation processors. So if you're not scaffolding the function from the CLI, you can just add a provider. You can add a provider to the build file, and add whatever dependencies you've got. So in this particular example, it's adding the AWS dependency in there, but there are other ones for GCP or Docker and all these. There are a lot of different deployment models that are supported currently. And then the other thing you have to do is is to set your project's main class. It has to be set to the function application class. So typically you'll do this in your build.gradle file. But you would, or if you're using, or your pom.xml, depending on what the build tool that you're using in. But you're really just basically defining what this class is. And then when you're configuring application to execute, really you can create a single project that defines multiple functions, but remember, only a single function should be configured for execution within that application. And so the easiest way to do this is to configure this with the Micronaut.function.name properly in your application YAML. The alternative is you can specify the value when you're running the function. And so you could do this, for example, in a Docker file. So if you're defining these to specify these in your Docker file, you can use an environment variable or a system property. And Docker also supports the open fast deployment. And that's just a feature you would have to enable when you're scaffolding a new project, or you can, again, add those dependencies manually. And you can also use the CLI-based execution of the functions as well. And I'm just going to pause here for a second because we're about done. I just saw the 5-minute warning sign. I guess we're done. All right, well, if there are no questions, that brings us to the end. Thank you so much. Thank you. Yes, question?
Can you show how does a function look?
So I've got, I had just a quick one in here for what the actual function looks like. So this is a really simple example of a function body. Actually, you know, with the lights off, this is really useful. It's really easy to read this. But the function body is really simple. There are really just two annotations. One is the function bean, and the other is, actually that's the only annotation. So you're just creating a class, annotating with the function bean annotation, and implementing the particular function the function base that you want to use, and then you've got the actual method.
This is what is created when you execute the command line.
Yeah. So it'll scaffold up basically an empty project that has all of the runtime and build dependencies with it. And so you would just create a class, and add those annotations for your function, and then you would typically define the function bean in your application YAML. So it's a pretty straightforward process. Any other questions? All right. Well, I've got a couple resources, acknowledgments in the back. I want to thank all the folks who have built really fantastic documentation and guides for the Micronaut community. So I've got a few things in here if you want to dive a little deeper. I want to thank the authors behind this, specifically Ivan Lopez and his RabbitMQ and Micronaut. That was the foundation for me learning a lot of this in the beginning as I was getting up to speed with all of the really cool capabilities in Micronaut. But thank you.
Big round of applause.